Base.
Crush it.
It's not bad. I can do a presentation for 8 people. Oh, one person left.
Adam, you'll see people jump in like all the way up until like 10 minutes after. No one shows up early.
I bet. Yeah, I know how that goes. It's understandable.
Hello, I'm Eric Matisik, co-chair of Denver Startup Week. Last year, we were able to bring the global audience together for Denver Startup Week, and this year, we're excited to welcome that global audience back as we celebrate and showcase the best of entrepreneurship that the Denver ecosystem in Colorado has to offer, in Denver and beyond. There are lots to explore this week, but most importantly, we're excited that you're joining us. We have nearly 50 sponsor companies who contribute to make Denver Startup Week possible. Let's show our love for these companies today and all week long. Thanks to our headquarters and title sponsor, Amazon, and our title sponsors whose leadership makes this week come to life, Capital One Cafe, the Downtown Denver Partnership, Fluid Truck, Hotel Engine, and WeWork, and our track sponsors who've made all the great content you're hearing today possible, which includes our founder track sponsor, Kickstart, our growth track sponsor, Friday Health Plans, developer track sponsor, Quizlet, product track sponsor, Palantir, design track sponsor, Battery 621 and the Public Works, people track sponsor, Exactly, and the spotlight event sponsor, Strat Labs. Our headline event sponsors are bringing this excitement to the entire week. Thank you to B-Side Fund, Colorado Public Radio, Comcast, Coors Brewing Company, Denver Pavilions, Entrepreneurship at the University of Denver, Gusto, JP Morgan Chase, Method, Moss Adams, Pi Insurance, Promontory Mortgage Path, Red Bull Basement, Southwest, Tattered Cover, and the VF Venture Foundry. Finally, thank you to our sponsors and member sponsors who are listed on the screen, and thank you for your support of Denver Startup Week. Now, let's get to it.
Hello, Denver. We are so excited to be here. We're excited to tell you a bit more about the Foundry for Builders program and to be a part of the Denver startup ecosystem. We moved our headquarters to Denver in the last year, and we're excited to call Denver home. Foundry for Builders. Essentially, we're offering our end-to-end Foundry solution that is deployed to major governments and enterprises worldwide to early and growth stage companies so that they can build their business on Foundry from day one.
Hi everyone, welcome to Denver Startup Week. My name is Ryan Margolis, and I'm the Product Track Chair and member of the Denver Startup Week Organizing Committee. Thank you for joining us for the 10th anniversary of Denver Startup Week. At DSW, we strive to make all of our sessions a space where attendees can connect, learn, and grow, regardless of age, gender identity, gender expression, race, ability, or sexual orientation. A special thank you to our sponsors for their support in helping us to keep DSW free and accessible for all. Thank you for joining us. Have a great week.
All right, everybody. I think we'll go ahead and get started. I appreciate Ryan and the DSW's team's help getting us rolling there, and giving a good shout out to the organizing sponsors and whatnot that make this possible. So let me go ahead and share my screen. As I get started, I've also got Laura Pozzi from the Crafted team with me. She's going to help us keep an eye on some chats, some Q&A, respond to some questions in the threads. I think what we're trying to do is mostly keep the questions and Q&A in the Zoom channel, not so much on the YouTube channel. So chime in there if you have questions, and we're happy to kind of pause the presentation and dive into those live as we talk through this. So we'll just jump right in. Laura, thanks for your help today. And we've got a decent amount to cover, so I may be talking pretty fast, and we'll see if we can get through this. After this, I also have some supporting blog posts and documentation that you can dive deeper into the topic. So as you know, or hopefully you know if you chimed in and are dialed in here, we're going to talk about APIs and databases 101. This is, from a Crafted point of view, this is mainly focused on like PMs and designers that are collaborating with balanced teams and trying to ship software, but it can go beyond that to marketers, QA people, really anybody you're looking to break into the tech scene that maybe has a more kind of novice technical ability. So let's dive in. Sorry, let's see here. There we go. All right. So real quick, who am I? And this will relate to my learning curve of going through APIs and databases. So born and raised in Colorado, been here a long time. I love seeing more and more people move to the area, despite it getting more crowded. So I've been around here my whole life and worked with various companies in downtown Denver for the past 15 or so years. More importantly to this topic, I started my career out of college, mechanical engineering, so not computer science, not real software based. And then I also got into real estate and land development, so I got even further away from technology and software. Then as the 2008 real estate crisis hit, I decided I shouldn't be in real estate and land development. So I got into some tech companies, wanted to get closer to my engineering background. And so I jumped into various forms of business analysis and software development. And that's where this topic became pretty clear to me that there's a big learning curve, but it can be really valuable if we dig into learning a little bit of depth in these technical realms. We certainly don't need to be software engineers, but being able to close that gap helps out. So that I then transitioned my career to product management through a startup here in Denver. That's when I got in touch with Pivotal Labs, who really built software a great way, helped them grow to an IPO back in 2018, and then jumped out to start Crafted, which is a balanced team consultancy. That's where Laura was first employee to join. Now we're up to 10 or so people with a network of good contractors, and we deliver software for companies. And that's where this thread, and we really like talking about this. We also enable a lot of product managers and designers with our clients. And this topic of going a little bit deeper on APIs and databases is always a very valuable thing as we jump into enabling clients and making them better product managers or better designers. So we hope you find it useful. So some of you may get this analogy right off the bat. Others, it'll be a little bit more clear as we get further into the talk today. So my first tech job, like I said, I was coming out of mechanical engineering and real estate, and I joined a tech company doing consulting, and I'm trying to get my feet wet and learn this stuff. And it takes me a couple of days to even figure out how to pull up a database and where to find it on my computer, and no clue where it's at, all this stuff. And this guy that was training me says, okay, now in the console there, start typing this, start type select star from, and we'll query this database and we'll get answers. So literally I typed what's on your screen here. So some of you will laugh at that. Others will laugh at it at the end of the call, and you'll realize how beginner I was when I was diving in. And at that point in my tech career, I just felt lost, right? I was swimming upstream, and there's so much to learn in so many angles. So we'll come back to this analogy and see if it makes sense for you guys at the end. Some of you are already laughing at me, which is great. So why do we spend time learning this stuff? Why does Crafted spend time teaching various product managers and designers this type of depth across databases, SQL, APIs, and JSON? So as we all basically know, we're in a more data-driven world. Everybody wants data-driven decision-making. We have tons of fantastic new tools at our fingertips, right? Like Google Analytics and Pendo, various other forms of data. Also, as we're building products, I think it's pretty common that a lot of us see that our customers and our users want insights surfaced in our tools, right? Whether it's graphs and charts and data sets and things like that. So these things are important to be able to define better products, go analyze our own products and understand what's going on. And if we're doing a good job with product management, we like to define better success metrics, right? So that's all data driven. The better you can understand data that's coming in and out of your system, you can define better metrics and get more specific and more actionable with those metrics. So across the board, understanding data, super important. Getting to the root level of like where it lives with databases and SQL will help you, right? As you dive into some of these tools that are at your fingertips, or when you go talk to your engineers. Then on the API and JSON side, why is it important? Why do we want to learn this? So with the massive emergence over the last 15 plus years of SaaS products, right? We're no longer having to build 100% of what our products do, right? Most commonly, we are integrating with other SaaS products, right? We're building some, but we're integrating with some. So you guys often will probably see where you need to go evaluate feature sets of those SaaS products and kind of understand the abilities to integrate with those products. So that'll help you with your engineering counterparts make the right decisions on choosing external partners. You can also then, as we've evolved technology, you've probably heard the terms of microservice architectures. So this is important that as you scale teams and as your architecture scales, often it is not one piece of software that you're building as a company. You may be, you probably have 20 or 30 different pieces of software that you're interacting with, and you're interacting across teams of engineers, other PMs. And the more that you can understand how these interactions between software systems happen, you can be a better product manager, better designer, and understand the trade-offs as you talk to your engineers. And all of that flows into better communicating with engineers. We don't need to be at the level, and we shouldn't try to get to the level where we want to solution the APIs and get into the implementation details. But you can absolutely understand why and when your engineers say something is easy, something's hard. Are we ready or not ready to do something based on some of these APIs and the communication between systems? And then lastly, with some of these distributed systems and other SaaS products and whatnot, it also helps you test your products better. As you start to ship and deploy software, a better understanding of some of this and what can go right, what can go wrong, will make you stronger at testing and understanding the flows of your system and where it might be broken or where it needs more attention. So hopefully that resonates and gives you a reason why we talk about this. And so what we'll cover. So on the database side, we're going to talk at a definitional level about what is a database, a schema, tables, and then we'll dig into a little bit more of the meat, very basic SQL statements, how to filter data, how we can run some logic against that data, and then sorting. Again, this is not just if you're specifically working with the database. This stuff helps out if you're in Google Sheets, if you're in things like Pendo and Google Analytics and things like that. So hopefully there'll be a good relation there. Then on the API and JSON side, we're going to cover the concept of CRUD, which you may or may not have heard of. And we'll go a little bit deeper on things like HTTP methods, status codes, and then we'll look at the structure of JSON, which is a really good thing to be able to interpret and get your head around a little bit. And then we'll go into some practical examples there as well. So real quick, just so I can take a breath, I'm gonna look at the chat, see if we have anything. Looks like Laura's taking care of that. So we're doing just fine. All right. So as we dive into this stuff, I want to frame this with an example so we can kind of get our heads around it and talk about it. So we have our fake example here is VRB&B. May sound somewhat unknown to you guys. And so it's a site where you can book travel. Homeowners can list their properties, and then travelers can rent those properties, right, and stay. So hopefully very something that you guys all know. So with that, we're going to talk about 4 very simple concepts that we'll tie our examples to. And really for today's talk, we're actually probably going to tie most of them to just 1 or 2 of these. So you have homeowners who have accounts to list properties on the platform. You have properties that are listed by the homeowner. Then you have travelers, right? So it's a 2-sided marketplace, homeowners and travelers. Travelers can research and book the properties. And then at the end of the day, what you really want is you want bookings between those homeowners, properties, and travelers. You want travelers to book and go to these places. So that's going to be kind of our analogy that we're working with today. And I'm going to click on it. Okay. The other thing that I'm going to occasionally pull up some examples of, depending on how I'm flown here with time, is we're going to use a database analogy where we have basically an example database that I'm going to use with Google Sheets. So Google Sheets, the entire system, the application of Google Sheets is basically synonymous with what we call a database. It can have many sets of data. It can have many organizations of data. Then, and again, we'll define these a little deeper. The specific Google Sheet that we're working with is similar to a schema. So hopefully you guys can see this screen. LP, can you give me a thumbs up if you see the spreadsheet? All right, thank you. So this specific Google Sheet itself, the entire sheet, is basically a schema for our VRB&B application. And then what we have is tables within that. So what you can see here is a tab on this spreadsheet is basically going to represent a table a table in our schema, right? So we have a homeowners table, we have a properties table, travelers, and then bookings. So those each represent a table. Let me do this real quick. Okay, so let me go back over here and we'll start diving into some of the definitions here. So database, like I said, in our analogy, it's going to be Google Sheets. What you guys may have seen in real life, you'll hear your development counterparts talk about things like Postgres, Microsoft SQL Server, MySQL, let's see, MongoDB, things like that. So probably some common terms. And really what a database is just an organized collection of data, generally stored and accessible electronically. Right. So that's a high level definition of the database. But again, it's kind of the whole Google Sheets application that then you can have a ton of different data sets within. Go a little deeper. So a schema, this is really where you get to more the nuts and bolts of a specific data set. So in our case, the homeowners, travelers, properties, and bookings, right? So what a schema does, it's your blueprint for your database. It really gives you all the instructions on how this stuff is structured, how it relates together. So it talks about relationships between the data. And then it also gives you basically the columns that you can have, which are variables of data that you store, and the constraints between those, the constraints of that data, right? So does it have to be numeric? Does it have to be a phone number, an email, things like that? It can also have constraints on whether or not it's required or optional and whatnot. Then if we go a step deeper into the database, we talk about the table. So a table, just like one tab on our Google spreadsheet, is a set of rows and columns and then cells. So the columns basically represent a variable, an overall variable that we want to store. A row is a set of data across many variables that represents one object, like a property. And then a given cell is a value of a property for that specific variable, like number of bedrooms, number of bathrooms for a very specific house. So that's kind of at the table level. And let's go a little deeper. So let's dive into just some very simple queries. Right now, we're just going to talk about querying data on one table, right? So a common setup for your queries, if you're dealing with most languages, is you'll have a select statement that says, I want to get data out of a table. I want to read data from a table. Then after you say select, you want a list of columns from tables that you want to query. And then lastly, you have a from statement, which tells the query, where do I want to pull this data from? This is where that first slide is going to be amusing as you start to see this. So when you say select star from properties, what we want to do there, that's basically telling us get all of the columns from our properties table, right? And return that. And it now makes sense where when I typed out star, I should not have typed out star. It's just an asterisk. And what an asterisk is basically just a wildcard for everything. It means get me everything from properties. And if we look over here at our spreadsheet, what that would basically do is return this entire set of data. It gives us every column from the data from that table, and it gives us every row. And actually, LP, give me a thumbs up. Do you see my cursor when I'm waving it around here? Okay, perfect. So yeah, by doing that very simple query, you're basically telling the database or the system, give me just everything out of that table and return it. So that's pretty common syntax. And there could be some small nuances between the various systems and whatnot. Then we can get kind of more specific when we want to return some of that data. So if instead of using the star wildcard, if we use select and then we give our query a set of columns, we can list them with comma separated values, still selecting them from the properties table, then the query will only return that set of columns. So we can kind of whittle down the information that we're getting from the system. So if we look here, and this is stuff that I'll share out as well. So our second query that we might do is returning just a small subset of the columns from that table, only the ones we care about. So again, it still returns all the rows from the database, but this time it only returned the 4 or 5 columns that we care about. So that is the intro there. We're going to go through some more examples here, but that is like your very basic, the most basic kind of query statements that you can run against tables and databases just to get all the data from a given table. And let me check on this.
So Adam, we had a question come through that do you recommend any online learning platforms to get a handle on the basics for JSON?
Yes, absolutely. LP, I know you and I both have like a list internally that both internal people and we give to our clients for enablement. So answer is yes, let us follow up with that offline. There's definitely some good ones on various platforms like Udemy and things like that, but we can follow up with the content that we publish here to get some of those courses out there.
Yeah, we can do it in our Get Crafty channel on the Colorado Product Slack.
Absolutely. Yeah. LP, do you want to put that Get Crafty channel in the chat?
Absolutely.
Awesome. All right. Thank you. Okay. So then if we want to dive into querying data a little deeper, and again, this will work if you're using Google Sheets or any of those other systems. But the next level of depth is filtering data and reducing the number of rows that we want to bring back from the database, because it's easier to work with. We don't want to overburden the system, and we can just get more specific with what we want to do. So that's where we start to add where clauses to our SQL statements. And that lets us, again, it lets us filter or reduce the data set. So you can, over on the left-hand side is where we'll talk about the various operators that you can use. So you can have queries where you want things that are equal to a certain value, not equal to a certain value, greater than, less than, greater than or equals, less than or equals. And then we'll talk a little bit more about these and, or in statements, which are really handy to use and can get you where you need to go pretty quickly. understanding some of this. So, if we start from the top to the bottom, simple one is select star from properties where state equals Colorado. And if we look over there, the analogy that Google Spreadsheet has for us, if we look at that, obviously it's going to return a data set that only has Colorado. The other thing that you can basically see ties in to this, that's no different than in Google Sheets. If you go in there and use their filter values, clear it, and if we were to select only Colorado, it's executing the same type of thing that you guys probably know how to do with Google Sheets, but that's kind of what it's doing behind the scenes. And then if you guys were to drop into a database or an analytics platform where you have to be a little more technical, that's basically what you're doing, is just saying where state equals Colorado. Then what is common with SQL syntax or some programming languages, but it could vary, is a not equals to can have something like an exclamation and an equal sign. So give me all the properties that are not in Colorado. So if we go back over here, that would be analogous to if we have everything selected and we deselect Colorado in this list and say, okay, can't necessarily see it on here, but basically now we should not have any Colorado data in our data set, which would be this data set. And then if we have it ordered, you can see down here that there's no Colorado states in here. So let's keep going. So then hopefully everybody's familiar with some of the math operators of less than, greater than. These things work really well when you're dealing with numeric data. It can absolutely be run on dates and things like that. And these, another good reason that we talk about in understanding these is like very often in our product management and design careers, we're having to build things like if we're talking about the VRBNB example, if you guys had to go build the search tools that power VRBNB, the homepage that you guys have seen on any travel site, it's really important to think about, okay, well, if we had a filter for bedrooms on the top of that, well, do we want it to be greater than or equal to? Do we want it to be only greater than, stuff like that? And what you'll see on a lot of those travel sites now is you select the number of bedrooms, but it says like 3+, right? So it doesn't necessarily just say 3 bedrooms, it says 3+. And what's happening behind the scenes there is that's the difference between saying, give me all the properties where bedrooms equals 3 or bedrooms is greater than or equal to 3. And it gives it's things that you guys can think through as you're designing user experiences and say like, okay, well, what power do I have with the data to make a better user experience? And do I want the user to tell me the exact number of bedrooms that they need? Or do I want to leave my result set broader, which is a common pattern? You want to give them the most options possible. So it's good for PMs and designers to be able to think through those strategies. And this is what you can do to help think about that. So obviously in this query with bedrooms greater than or equal to 5, you do get everything with 5, 6, 7, 8 bedrooms and tie those in. So, and I won't switch back to the spreadsheet every time. So if we talk about these next one, they get interesting. What we want to do here with an and clause is as you build a query tool, you often have multiple variables that a user's selecting. So in this example, what we have is we want to find a property in Colorado and it must have 7 bedrooms. And we'll talk about the difference there of using ands versus like or statements, which are very different user experiences. So obviously in this case, you probably have a big family trying to travel. They want to be in Colorado and they need to make sure that they do not get a 3-bedroom house. So this type of query where you can start to layer on logic to filter will ensure that you get Colorado houses with bedrooms greater than or at equal to 7. So if we look at our query results, we need to go to query 6. So again, if we take a step back and only say, sorry, I'm gotta find my right query. So if we only query properties that are in Colorado, you guys can see that we have a handful of properties and there's a whole slew of different bedroom configurations here. But what this user is telling us is that they specifically wanted in Colorado and they need 7 bedrooms specifically. So we have it equal to. And obviously that reduces the data set for your user and your user experience. You've now honed them in through a massive amount of data to specifically what they're asking you for. And that's how the query might look if you were to build that in SQL using an AND statement. So let's jump over here. So then we have the difference between an OR statement. So what often happens with AND statements is you're getting more restrictive. You're kind of telling the data that it has to meet several criteria, and they all have to be true in order for that data to come back. If you use OR in your filtering criteria, it gets more broad, right? Because you're basically giving the data in the result set more chances to have a true statement. So what we have here is a couple of different examples. Let's look at this second one first. So as you guys can imagine, if you use OR in your SQL statement where you're saying state has to equal Colorado or Utah, you can imagine that now you just maybe not doubled your data set, but you left it twice as open so that it can return more data, right? This is the example of the users. They want to go skiing, but they really don't care if they end up in Colorado or Utah. So by doing this type of query and using OR, you just left your data set more broad to find more possible results and help the user get to what they want to across those states. Likewise, you could do this across different columns in your database. So you could say the city has to be Atlanta, or the zip code can be this, which is somewhere outside of Atlanta. It's an Atlanta suburb. So again, that says, hey, find properties in Atlanta proper, or I'll go over to this zip code because I know I want to stay there. So again, you're giving it a more broad data set if you use the OR statement. So that's the difference between ANDs and ORs. ANDs are typically more restrictive, ORs are more broad and give you more possibilities typically. And then the last one we'll talk about, which is in. In is another way, just more shorthand of doing an OR statement. So really these last two lines in this example are the exact same. So by using an in, it's basically you're saying where, select all the properties where state is in a list of states. So it's the exact same of what you get here with Colorado or Utah. It's just more shorthand and more concise as you are going through that. All right, so we'll keep moving on here. Okay, so then we can talk about ordering our data, which basically just gives us a way to compare things, sort them in the correct order so that you can see things more side by side. This often comes in valuable. For instance, we have some examples here where you're sorting by the number of bedrooms, right? That might be a very common aspect that you're looking to do because they want to see the biggest houses first, or they may have said greater than 6, so you want to see the biggest houses and where I have the most options for bedding. You may also want to compare, like if you had your two states of Colorado and Utah, you might want to sort them by states so that you're seeing the Colorado states show up in one grouping and then the Utah states show up after that in our previous example. So I won't spend a lot of time on the sort by. I think you guys are familiar with it with Google Analytics and various reporting tools and Google Sheets. It just basically gives you a really good way to compare data if you can organize those fields in a good way. Okay, so let me check time at 11:32. So we're tracking okay. And now we're going to jump into APIs and JSON. Just as a reference for anybody on the call, that's about the level of depth we're going to get to. We're going to do a similar dive into APIs and JSON here. Hopefully it's helpful. Certainly if you're at a different depth and are already kind of beyond this, that's fantastic. We also back this up with some more content that'll help you guys out if this is a good level for where you want to be. All right, so let's talk APIs and JSON. Okay, so first thing that we talk about is for an API, you probably often hear the term endpoint. What that is basically the URL that these systems are talking to. It literally looks like a URL that you would see in your browser. Sometimes it'll have a little bit more technical information tied to it. but it's basically an address of where we're going to communicate back and forth across these software platforms. If we, make a very rough analogy, and this is where, some engineers may have different ways to make analogies here. But an analogy, if you want to call someone, the endpoint for that call would be their phone number. It's where I need to get in touch with another system to have communication. And if you were to send a letter, an actual handwritten letter, then the endpoint would be their mailing address, right? So it really is just kind of that address that we're going to be talking to. Okay, so you guys, I think most common for product management and designers is you've probably somewhere along the way heard the term CRUD, which is create, read, update, or delete. And those are the types of actions that you're taking on data. Hopefully that's pretty familiar. If not, as you keep progressing into your tech career, it'll certainly become very evident. Almost everything we do with software kind of evolves around some aspect of CRUD operations, various pages and whatnot. So then where it dives into the slightly more technical layer is where we talk about HTTP methods. You don't have to know a ton about HTTP, but you'll probably hear your engineers talking about it. And what they'll start to talk about slightly, engineers absolutely use the CRUD terminology, but they'll also start talking about things like these HTTP methods, which are post, get, put, patch, delete, and there's certainly a few more. These are the 101 course ones that we're going to cover today. So as you hear an engineer say post, get, put, patch, or delete, now you have a way to kind of translate what they're saying. All right. So when we say we want to create something in our software system, when you use APIs, you're most often using like a post, and you'll hear an engineer say we need to post data to an endpoint. If you're reading, and actually another good way to think about reading, which is probably more common to what we know, is viewing data. So reading data is really viewing data from a human standpoint. It's showing data on a screen that already exist in the database or in the system somewhere. And what the engineers will refer to there is get. We want to get data and show it on the screen. Diving a little bit deeper, we then have updates. We'll talk about two different types of updates in a brief fashion here. So you'll hear the engineers then say put or patch if they're talking about the API endpoints. They'll say we're going to put data or we're going to patch data. Putting data is basically we're taking the entire representation of something. We're going to send all that data back to our systems and they're going to update it with the new picture of that data. If we patch something, we're only sending one very specific variable and we're going to update it. So for instance, if I'm set up in a software system and the only thing I need to update is my email address, well, you could use a patch to only send my new email address, and that's the only thing that the API needs to know about. If you were to do a put, then you have to kind of send all the data about me, and the system takes that as a new representation of my record in the system. And then the good thing here is delete. What engineers talk about is a delete. I think not only on the engineering side, but what we need to know and talk about from a user side is a soft delete versus a hard delete. Some of you may know this terminology pretty well. And it's also what you may see it in current systems as is thinking of it in the archive sense. So a soft delete only kind of archives data, or it disables it, and you might then have a flag that allows you to hide it and not show it in user interfaces. And like when you archive an email, it goes somewhere, it's out of view, but it's not gone. It's not fully deleted. And then a hard delete is just that. You wipe it out of the system, it's out of the database, it's kind of gone forever. What I would say is I'd say it's much less common these days to worry about fully deleting data. You typically will soft delete it because in this day and age, like storing data and keeping data is not a problem. It used to be a big problem and you used to worry about database size much more than you do now. So from a product management and design aspect, it's good for you to know like soft deleting data, and then you can design your user experiences to understand that. And where does this hidden soft deleted data go, and how can we get that back for a user if we need to, but it's also good for you to know like it doesn't go away, so you can always go back and understand that data and re-access it if needed. Okay, so that is how we kind of map our CRUD terminology that is more common to engineering terminology that we'll talk about with APIs. This one I'm going to go over pretty quick, definitely getting more technical and a layer deeper, but it's also good to know. So important thing on this slide is just go look up these HTTP status codes. You can learn more about them at a much deeper layer. What I think is important at this 101 introductory level is that if you are working with some APIs or with your engineers, maybe you're using a tool like Postman where you can kind of practice with some APIs. When you send a request and get a response, these status codes are going to give you a good bit of information of like what's going on. And it'll let you have that first layer of, okay, how can I go figure out this problem a little bit on my own, be a little bit self-sufficient, maybe before running screaming to the engineers. So these are bucketed into groups of basically 3 digits, and they're kind of segregated by like the 100s, like every starting spot is a different one. So the biggest and best ones that we care about are things that start with a 2, 200, 201s. These means things are working well with your API, and you either sent a successful request, which is like a 200. If you're doing a post, you created something successfully, things like that. So ideally, you're looking for stuff that comes back and you get some sort of 200 level message, and that means things are hopefully good. The next most helpful ones for this audience are these 400 level errors, and those tell us something's going wrong. Like when we say client, we're talking about our like front end applications, the applications that our users are dealing with. And a lot of these 400 level errors are going to give us good feedback and good information of like, hey, the user's not authenticated, or there's some validation errors, things like that. So that's a good level of depth that hopefully you'll get good information back from your API. And you can kind of make a little bit of sense about what's going on. At a minimum, if you're trying to help debug it with your engineers, you can tell them, hey, I got this error. I can capture this message and send it to the engineers, and that'll help them out. And then a couple more to talk about at 500 level errors. These are deeper down in your tech stack, in your servers, and in your applications. That usually means like, go talk to the engineering team. Something's broken. You're probably not going to fix it as a PM or designer or other. So if you see a 500, means something's going on with our systems, go talk to somebody. And then there's this kind of surface level one of 300 level errors, which are basically things moved. One area of 300 level status codes that we do care about that comes up quite a bit as we build software systems is marketing efforts. So a lot of these you can do redirects, and you'll dabble in this realm as product managers, maybe designers, but mostly product. If you're standing up new systems and you want to maintain things like SEO, and you care about current URLs that are out in the wild, but you're standing up and publishing maybe new web pages, new applications to new URLs, you'll care a little bit about some of these 300 level errors, where you can move that content, maintain some of your SEO and whatnot. So if you have some of those, go look at these codes. You'll dig into them deeper, but you may care about those if you're moving websites and want to maintain SEO. I'd say that's the biggest one to keep in mind, like on that realm. So, okay. Let's keep moving here. So JSON, which is JavaScript Object Notation. This is interesting. This puts a lot of power in our hands of understanding. I think this is a really good translation between the engineering and PM tech world. If your engineers were to send you some JSON and talk to you about this, just being able to read through it and see how it's kind of structured is fantastic, and it'll give you a lot of power to kind of understand. Again, communication with your engineering team should never be a second thought. It should be the first thought, but hopefully this also layers on your ability to read through some information and data. So we'll dive into some good examples as we move on. But what we have here is there's 3 kind of main areas of JSON that I think will get you started and get you understanding how to read it, right? So the first and the most granular piece of JSON is these name value pairs, sometimes called key value pairs. And what we have here is with, within quotes, some of the syntax will vary, but you have the key or the name, and that's really of a variable, right? So that when we say name or key, it's a variable. Then on the other side of a semicolon, also typically in quotes, is a value for that variable. So in this example, we have, first name is the variable and Adam is the value of that variable for this very specific case. So that's a key value pair, name value pair. Then the next kind of level for JSON is objects. So an object is within a set of curly braces, and it basically just defines, like it groups together a set of variables that talk about an object, right? A certain thing, right? So the example I have here is, maybe a person object. And obviously these things can get much more robust and go a lot more in depth than what we have here. But the object that we're representing here is a person, and that person is made up of three things. So first name, last name, and age, right? So again, then we use key value pairs. You see those are after each one of these key value pairs, you use a comma to let the system or the JSON know that you're on to the next variable. And that this basically represents me as a person in this system. Then the third kind of idea that we have in JSON that'll help you read through it is this idea of arrays. Occasionally they're called lists. I think probably the more engineering related term is array. And an array or a list of things is denoted by these square brackets. So you can kind of know that if I'm looking at something in JSON and it's wrapped in square brackets, then okay, it's a list of something. So the example I have here is a list of my family members, wife, daughter, son, and it's just a list of names. Not a lot of good content or information on those, but we have a list that you could use for certain purposes within your system. So those are the three main constructs of JSON. If you know this much about them, as you then start to read through JSON, you can say, okay, I'm making sense that things within the curly brackets, those are representing something, right? They're telling me that is an object. They're all kind of related. What is that thing within my JSON versus list? And then now you know more about key value pairs. All right, so let's get into some examples. And I think we're going to be doing just fine with time. Hopefully we're not moving too fast or too slow. Let me move the screen here. So let's look back at our VRBNB examples and tie this stuff together a little bit. So if we, in example one, we want to view a list of all properties. So as you guys can imagine, when you go to VRBNB website, the first thing you're gonna probably see is either a bunch of listings of properties. Maybe you have to tell it like a city or state first because you don't want to return 7 billion houses to the website. But as soon as you do something to search for where you want to travel, you're going to see a list of properties come back to the front page of that website. So again, if we tie these things together, what we're doing on the CRUD operation there is reading data. So as we tie in our API, that's doing a get, right? It's doing a get from a database somewhere, and it's saying, get me all the properties. So our endpoint, kind of the address that it needs to know to go find that information, it may be something that looks like this. Again, this could vary a ton, but I think you guys get the example that basically we're sending it to this /properties endpoint saying, get me data, and it's going to return a big chunk of JSON information that then we can render on our website, make it look really good. Some of that data may have latitude and longitudes where we can plot it on a map and do all kinds of fancy things that these systems do. And what we did there, if we do a get to this endpoint, hopefully with the JSON on the right side, you also get a status code 200. That means you did a successful get, and it returns this big list of properties. What I'm showing here on the screen is one full property and then shows the second one with the ellipsis. This could obviously be thousands of properties that come back in this API response. And you can see there that what we have here is the square brackets represent that we're getting a whole list of tons of properties back from the system. Then with each, so that's an array, right? We're getting an array of properties. That array is made up of a bunch of property objects. So again, if we go back to the previous slide, the curly brackets represent a given property. And then within those curly brackets is all the data that tells us what that property is, right? Address, city, state, zip, bedrooms, bathrooms, square feet, all that good stuff. So that, and then what we can do there is also we separate the objects the property objects by a comma, and then you can start having multiple properties come back in that JSON, and it can be a long list of properties. So if we go on to one more example. So then let's say as a user, we're on that front search results screen and we find the perfect property out here in Hawaii. We want to dig into that and look, common flow is you then go to the property detail page where you get to see awesome images and details about the property. So what would happen there is again, we're still reading data or getting data, but now it's for a specific property. We want to dive into that property itself and look at the images and the details and reviews and all that. So what we're doing there is doing a read, which is a get to an endpoint. And what you'll see here is the difference on that endpoint is that now at the end of the endpoint, we specify a very specific property. Because as a user on that user interface, we just clicked on a specific property, taking us to a new page. And so now it's saying, okay, get me the details for property 1. Again, assuming the system's healthy and happy, if there is a property 1 in the system and nothing goes wrong, we'll get a 200 back and it'll return the data. What you see here is now it's only returning the data for one specific property. It still might be structured like a list, but in this case, it's a list of just one. You don't have all the other properties kind of tied on behind the scenes. And then from a user interface standpoint, we can now render this in a very pretty way and make it look great for the users. The other good reason to touch on why it's important to understand this type of syntax or even the database is a designer or a PM, you might go to your engineering team and say, hey, what data do we have available for a person or a property or this or that? Where if the developer just sends you back some JSON or sends you back a database query or whatnot, now you can take that data and realize like, okay, here's what I have to work with in my user experience. And here's how the data looks and feels like. Is it numeric? Is it text? How can I treat those differently on the user interface? All right, so let's go one more example. So creating.
Adam, we had a question come through.
Yeah.
Brendan asked, does the HTTP method go within the endpoint URL so that the endpoint knows what you're doing, or is it handled another way?
Yeah, good call. So it does not get placed in the actual URL here, like in this text. So you wouldn't see something here and see post within this URL. But as the developers write the code that's going to execute these requests, part of it will be, well, what method is it? And what is the endpoint? So they'll send all this data together with an API request. So it'll say it's doing a post and to this endpoint, so separately. And if you have worked in Postman, which I'll pull up if we have time here at the end, you do a very similar thing. In Postman, there's a spot where you put your endpoint URL in a field. Over on the left side of that, there's a drop down where you say, what am I trying to do? And that's the HTTP method. You're saying do a post, a put, an update. So the combination of those two things separately is what tells the endpoint what to do once it gets received. All right, so keep going here, but definitely keep the questions coming. LP, interrupt me if you need to. So creating a new property. So a little bit different now. So the first ones we did were reads and gets. Now we're going to level deeper. We have a new homeowner on the platform and they want to put their property on the platform and give us some details. So what they want to do is create a property in our system. What we're going to then do from an API standpoint is we're doing a post. And again, we're doing it to the /properties endpoint because that's what we're creating. We're creating a property. You'll see now we've reverted back and we are no longer using the ID at the end of it because the ID doesn't exist yet. We haven't created anything. So you're just generically telling the system, I'm creating a property. You're sending it to this kind of abyss of property, workflow and code, and it's going to know what to do because you now gave it a post and we're giving it a request body over here on the left. So even the property doesn't exist yet in the system, but what we're doing is we're giving it the details to create that property. And the difference you see on the left and right side with the request, we don't have an ID, right? Because it hasn't been created yet. Then what will commonly happen if it's successful and you've given it all good data and it's validated and whatnot, you'll get a 201 status code, which means the property was created, it was successful. And now you often get all the details back so you can confirm them if you need to or whatnot. But now you have an ID. So now the property was created in the system. You got that back 201. Now you can do the next steps of that property, whether it's publishing it, booking, reservation, stuff like that. All right, so I'm going to move on. We have 3 more examples. I think we're going to be spot on time and maybe some Q&A if needed. Okay, so updating a property. And if I go back a screen, let's look at this property you recreated. It has 8 bedrooms, 1 bathroom, slight mismatch there, but it's a pretty sweet house as long as you don't have to use the restroom. So what we realized there is I did something wrong in the UI. I don't have an 8-bedroom house. I have a 5-bedroom house. So we're letting the homeowner update that. What we want to do there is now the home, like I said, the homeowner's updating their property. They want to do a put, or the engineers are telling us we're going to do a put. So that's going to make sense to you now as a PM or designer. And what we want to do there is we're back to the same /properties endpoint. This time is, so we keep flip-flopping. This time we are using the ID because we need the system to know exactly which property we're going to update. We don't want to set somebody else's house to 5 bedrooms. We want to set our specific property to 5 bedrooms. So in the URL, we would send that over, and I missed that example, but at the end here, we would say property 99 is the ID that we're going to update. And the user probably has a form up that they're editing it from 8 and now it says 5 and they hit submit or they hit save. That's going to kick off this process to do the put. And we're going to have it at 5 bedrooms. What we're going to get back there is hopefully a 200 status code that says, hey, we're done with that. That was successful. We're happy. Then it'll often return that same set of data so you confirm, and now we should see that it says 5 bedrooms versus 8 bedrooms. And you've now updated it for the system. You can then show that in the UI that they're all set and they're ready to go. All right, 2 more. Delete, relatively simple API requests. Lots more going on behind the scenes on how the engineers would handle this and keep the system happy. So again, delete on the CRUD operations and the HTTP methods, same thing. So you're going to send a delete. Obviously, in this case, we want to send the ID with it because you need to delete a very specific property. You don't want to delete somebody else's property or the wrong one. So we'll send that property 99. And really what we get back there, there's not a lot of body that you get back in the request or the response. It's just going to say 200, we got it, we deleted it, you're happy. Going back to the quick analogy of soft delete versus hard delete, it's a good example of what's probably going on behind the scenes here is a soft delete. This property, maybe it has existing bookings, maybe it has historical bookings against it. You don't want to delete that out of your system. You want that for historical purposes and data and analytics, and they may come back and reactivate the property. So oftentimes what a delete is doing is just disabling it, deactivating it, things like that. So again, hard deletes versus soft deletes, keep in mind both from a technical aspect and from how you deal with those on the user experience. Okay, last example is slightly more complex, but not too bad. So now let's say we want to view all bookings for a specific property. So the use case here is the homeowner wants to go in and they want to see how their property in Vail doing. How many bookings do I have on that property in Vail, Colorado? So they're going to click on the property. There may be a tab on the user interface that says, bookings for that property. So what's happening behind the scenes there is again, we're just viewing those bookings. So we're doing a read. We're back to doing reads, which for the engineers, they're going to talk about they're getting data out of the database. Now the URL looks a little bit different here, which is pretty neat. And this is just the next layer of depth of understanding JSONs, endpoints and URLs. So what we're doing here is we're saying for a property of ID X, get me the bookings. And that's where you often see these start to add up. But now you can read through these URLs a little bit better. And we're saying down here, if you look at the actual example, it's saying, okay, we're doing a get from the /properties endpoint for property 12, but the endpoint is a little bit deeper into the system. It's saying for that property, specifically get me the bookings for that property. Then what you get as a response is a list of bookings. If it goes well, you're getting a 200 status code. So let's look at this, and this will close the loop on our JSON, and we're going to be done here, which is the last slide. So again, we're getting a list of bookings. So if you go back to your square brackets, that's a good way to interpret as a PM designer. Okay, I'm getting a list of things. How can I interpret that? Within that, you have the curly brackets, which represent an object. Well, what object is this? Is it a property? Is it a booking? If we look at it, it's pretty easy to tell, and it makes sense with our example. The object here is a booking, right? So it has ID, property ID, traveler, check-in, number of nights, travelers. So you can start to make sense that, okay, this thing represents a booking. And because it's a list and we have a comma with another booking, you can tell that you're getting many bookings back. So for this specific property, we do have at least more than one, in this case, 2. You may also have, 50 or 100 or whatnot. But now you can kind of interpret what's going on there with these key value pairs, the objects, and the list within the JSON. That is it, people. We're right at noon. That's perfect. I did not think that would happen. LP, do we have any final questions?
None that have come through.
Awesome. All right, guys. Well, we really appreciate you tuning in. Love to talk about this more. We will publish this plus additional content that backs this up and talks through it. But reach out to myself at crafted.solutions, Adam at crafted.solutions. Chime into the Get Crafty channel on Colorado Product. We'd love to stay in touch, and we love talking about this with people. So thank you for tuning in. We appreciate it.